SQL joins are clauses used to combine rows from two or more tables based on a related column between them. This relational structure prevents data redundancy by linking unique identifiers across different datasets. An inner join returns only the records that have matching values in both tables. For example, joining a customers table with an orders table will only display customers who have actually placed an order.
The left join returns all records from the left table and the matched records from the right. If there is no match, the result is null on the right side, allowing you to identify employees not yet assigned to a department.
A right join is the mirror of a left join, returning all records from the right table and matches from the left. It is frequently used to find orphaned records, like authors in a database who haven't published any books yet. The full outer join returns all records when there is a match in either the left or right table. This creates a comprehensive view of both datasets, populating nulls wherever a match is missing on either side of the join. A cross join produces a Cartesian product, matching every single row from the first table with every row from the second. This is used for generating all possible combinations, such as every available color and size variant for a product line. The inner join is the most common join type. It returns only the rows where there is a matching value in both the left and right tables. Mathematically, this represents the intersection of two sets. If a record exists in one table but lacks a corresponding key in the other, it is excluded from the result entirely. In practice, an inner join is used when you only want to see data with a complete relationship, such as a list of customers who have actually placed an order. A left outer join, or simply left join, returns all records from the left table, regardless of whether a match exists in the right table. When no match is found on the right side, the result set populates those columns with null values. This ensures you don't lose any data from your primary left side table. Use a left join when the left table is your source of truth, such as generating a master list of all employees while optionally showing their department manager details. Conversely, a right join returns all records from the right table and only the matched records from the left table. If there is no match for a record in the right table, the result set will contain null values for every column from the left table. Use a right join when you need to audit your secondary table, such as finding shipping providers in your system that haven't been assigned any orders yet. Technically, a right join is just a mirrored left join. Most developers stick to left joins for consistency and readability, simply swapping the table order. A full outer join is the most inclusive. It returns all records when there is a match in either the left or the right table records. This join essentially combines the results of both left and right joins, ensuring no data is dropped from either side, regardless of whether a match exists. To implement this, we use the full outer join syntax. It requires a joining key, just like inner and left joins, to determine which rows align and which remain as orphans. A real-world use case is merging two customer databases after a company merger. You need a complete list of every unique customer, preserving data from both original systems, even if they don't overlap. Note that MySQL does not natively support full outer join. To achieve this result in MySQL, you must perform a left join and a right join, then combine them using the union operator. Next is the cross join, also known as the Cartesian product. Unlike previous joins, this does not look for matches. It pairs every single row of the first table with every row of the second. Because it creates every possible combination, no join condition or on clause is used. The resulting row count is always the number of rows in table A multiplied by the number of rows in table B. This is ideal for generating permutations. For example, if you have a list of products and a list of available colors, a cross join instantly generates every possible stock keeping unit, or SKU, combination. Mathematically, this is known as a Cartesian product. Because there is no on clause to filter the results, the output size is always the number of rows in the first table multiplied by the rows in the second.
Be cautious. Cross joins scale exponentially. Joining two tables with just 1,000 rows each results in a 1 million row result set, which can easily bottleneck performance or crash a database if used accidentally.
Next is the self-join. Despite the name, this isn't a separate SQL keyword. It is a technique where you join a table to itself to compare or relate rows within that same dataset.
The most common use case is hierarchical data. Imagine a staff table where one column lists the employee and another lists the ID of their manager, who is, of course, also an employee in that same table.
To perform a self-join, you must use table aliases. This tells the SQL engine to treat the single physical table as two distinct logical entities, allowing you to map child rows to parent rows effectively. Beyond hierarchies, self-joins are essential for finding patterns within a time series, such as identifying customers who made a second purchase within 30 days of their first transaction.
To execute this, we alias the same table twice. By joining orders 01 to orders 02 on customer ID, the database creates a virtual matrix comparing every purchase against every other purchase made by that user.
A simple equality join on customer ID creates redundant data where an order matches itself. To isolate two distinct transactions, we must refine the join condition to exclude these self-matches.
Moving from specific relationships to total combinations, we reach the cross-join. Unlike every join we've covered so far, the cross-join does not require a matching key or an on clause. This creates a Cartesian product. Every row from the first table is paired with every single row from the second, resulting in a final table size equal to the product of both row counts. Cross-joins are the standard tool for generating master lists or grids, such as creating every possible combination of product variants, sizes, and colors for an inventory management system. However, use cross-joins with caution. They produce a Cartesian product, where the result set size is the product of both tables' row counts, which can easily crash the system if applied to large datasets.
A self-join is not a unique keyword, but a technique where you join a table to itself. To do this, you must use aliases to rename the table instances so the SQL engine can distinguish between them.
This is the industry standard for querying hierarchical data. In an employee table, the manager ID column references an employee ID in the same table, allowing you to pair every staff member with their supervisor. Self-joins are also used to find internal patterns, such as identifying customers who placed multiple separate orders by joining the table on customer ID while filtering for non-matching order IDs. Next is the natural join. This syntax shortcut automatically creates a join condition based on all columns in both tables that share the exact same name and data type. Despite the convenience, natural joins are risky. If someone adds a column like created date to both tables later, the join will implicitly include it, often leading to empty results or logic errors in production. To solve the unpredictability of natural joins, SQL offers the using clause. It provides the same clean syntax, but requires you to explicitly name the shared columns, preventing accidental matches on metadata.
The using keyword is a shorthand for an equijoin. It is only valid when the columns you are joining share the exact same name in both tables, making the query more readable than a standard on clause. A specific benefit of using is column deduplication. While a standard on join includes both source columns in the result set, using automatically merges them into a single column in the output. Moving to a different logic, the cross join, or Cartesian product, produces a result set where every row from the first table is paired with every row from the second table. Because it creates every possible combination, no join condition is required. If table A has 10 rows and table B has 10 rows, the resulting cross join will always contain exactly 100 rows.
Cross joins are rare in daily reporting, but essential for generating master lists of combinations, such as creating every possible variant of a product across different sizes, colors, or warehouse locations. While most joins combine two different tables, a self-join allows a table to join with itself, effectively treating a single source of data as two separate logical entities. This is the standard solution for hierarchical data, such as an organizational chart, where an employee's manager is simply another employee listed in the same roster.
By matching the manager ID from the first instance to the primary ID of the second, you can generate a report that displays the subordinate and supervisor names side by side.
In SQL, table aliases are mandatory for self-joins. You must rename the table twice so the database engine can distinguish which instance provides which column. A natural join is a syntax shortcut that automatically joins tables based on every column name they share in common, removing the need for an explicit on clause.
Be cautious. Natural joins are risky in production. If both tables contain a generic column like ID or created at, the join will fail by trying to match those unrelated values.
To avoid the risks of natural joins while keeping syntax clean, SQL provides the using clause. It allows you to specify exactly which shared column name to match on, preventing accidental mismatches. Unlike the on clause, using requires the column names to be identical in both tables. It also automatically merges the join columns into a single column in your final result set. Moving beyond multi-table joins, a self-join occurs when you join a table to itself. This is a powerful technique for querying hierarchical data stored within a single table structure. Consider an employees table, where each row contains a manager ID. To display the manager's name alongside the employee, the database must treat the table as two separate entities during the join. Table aliasing is mandatory in a self-join. You must assign unique temporary names like E for employee and M for manager, so the SQL engine knows which instance of the table you are referencing.
Self-joins are the industry standard for generating organizational charts, identifying duplicate records with different IDs, or comparing a row's value to the row immediately preceding it. To build a hierarchy, we alias the table twice, once as staff and once as managers, linking the manager ID back to the primary employee ID key.
To identify duplicates, join the table to itself on matching data points like email, then filter where the unique IDs differ to isolate redundant entries.
Moving from specific matches to total combinations, the cross-join or Cartesian product returns every possible pairing between two tables, regardless of relationship.
Unlike other joins, a cross-join requires no on clause. If table A has 10 rows and table B has 10, the output is mathematically fixed at 100 rows. This is most useful for generating master lists, such as creating every possible combination of product colors and sizes to initialize an inventory matrix. Exercise caution. Joining two tables with just 1,000 rows each creates a million-row result, which can easily crash your session or exhaust system memory.
Despite the risk, cross-joins are intentional when you need every possible combination, such as generating an inventory matrix for every color and size variation of a product.
A self-join is not a unique keyword, but a technique where a table is joined with itself. It allows you to compare rows within the same dataset as if they were two separate entities. To perform a self-join, you must use table aliases. These temporary names provide a reference for the SQL engine to distinguish between the left and right versions of the same table. The primary use case is hierarchical data. By joining the staff table to itself, you can correlate a manager ID column to the employee ID in the same table to retrieve supervisor names. Self-joins are also essential for finding duplicates. You join the table on the matching value you're investigating, while ensuring the primary keys are not equal to avoid matching a row to itself. Note that while you define the logical join type, The SQL optimizer decides the physical join method, like a hash join or nested loop, to execute the query with maximum efficiency. To maximize join performance, ensure your join columns are indexed. This allows the engine to perform an index seek to find matching rows instantly, rather than scanning every row in the table. Always apply filters using where clauses as early as possible. Reducing the row count before the join operation minimizes memory usage and prevents the optimizer from processing unnecessary data. From standard inner joins to specialized self-joins, understanding these logical relationships is the core of relational data mastery. Choose your join type based on the data you need to include or exclude.